In this video, we're going to learn how to find the area of a sector within a circle. We're going to talk about the formula, define the word sector, and then go through a couple example problems how to solve for missing variables. First, a sector. In a circle, you have a radius and a center. A sector is essentially a piece of the pie. And that can be however big that theoretically however big you want it to be, or however big the problem says it is. This is a sector. It has to go to the center and essentially is a fraction of the circle itself. Now, how big is the fraction depends on the central angle of it. We should all know that the entire angle all around the circle is 360. That's going to help us define how much of the circle the sector takes up. Let's look at the area of a sector formula. We're going to use capital A as area. It's going to include the old area formula of a circle that we've already learned about. So this is the area of the entire circle. Now this first piece here, it's going to be a fraction. We're going to figure out how much of the circle we're actually going to find the area of. So the entire circle is 360. And we find out the fraction by simply taking the angle of the sector and putting on top of this fraction over 360. So we usually denote angles with the Greek letter theta. So we'll use that here as well. And this piece, this fraction, is going to answer the question, how much of the circle is the sector? How much of the circle is the sector? So this piece is how much of the circle is the sector. This piece here is the entire area of the circle. So if theta were 360, for example, that would be the entire circle. If theta were just 1 degree, it'd be a very small little sliver of a sector. It'd be a very small portion of the area. So you have 3 variables here, capital A, theta, and r. So if I'm asking you to solve for one of them, I need to give you 2 other ones. So if I ask for area, you need to have theta and r, or radius. If I ask for theta, the angle, you need to be given area and the radius. And lastly, if I ask for radius, I need to give you the area and the angle, central angle theta. Let's look at an example like number 4 here on the paper. We'll zoom in. It tells you the central angle is 315 degrees. It says the radius is 10 meters. And the directions say find the area of each sector. Round your answers to the nearest tenth. So we're going to rewrite the equation. I'm going to plug in my known values and solve for my unknown values. So the directions state that I'm solving for the area of the sector. So that's this capital A. We don't know what that is right now. Ask yourself, do we have the central angle theta? We do, right here. Check that off our list. Do we have the radius? R. Yes, we do. It's 10. Plug in your known values. And since we have nothing to solve for, or the A is already by itself or isolated to solve for, we can simply type all this in the calculator. So typing it in essentially as you see it. So 315 divided by 360 times pi times 10 squared. And we get an approximate area of the sector of 274.9. We round to the nearest tenth. So this 8 brings this 8 up to a 9. So 274.9. And since the units for the radius is meters, the units for the area is going to be square meters. That's finding just the area of the sector given the radius and the central angle in the diagram. But let's say they give you a different set of circumstances, like this example here. States an area of a sector of a circle whose central angle is 100 degrees, has an area of 350 square meters. Find the radius. So in our formula, which I'll rewrite down here, of our 3 variables, capital A area, they give to us right here. Central angle, 100 degrees. We have that. Find the radius. That r we don't know. So we're going to plug in these two numbers in their respective spots and solve for that missing r variable. So 350 goes in for A. Theta is 100 times pi times r squared. So right now, we want to solve for r. We want to get that by itself. So a few things. I need to get rid of all of this and the power of 2. Power of 2 means I'm going to square root at some point. Not yet, though. I want to get the r squared by itself first, and then square root it. Before I square root it, I got rid of all this stuff. You could do this in 2 or even 3 steps, or the other option is to do it all at once by using the multiply by the reciprocal method. So I'm going to make 2 empty fractions here. And the rule of thumb is reciprocal is a flip. So whatever's currently on top, you write on the bottom. Whatever's currently on bottom, you write on top. And effectively, they'll cancel out to 1, isolating the r squared. So look first here, 360, clearly the denominator. So that's going to go to the top of this fraction, 360. And watch what happens, 360 over 360. They cancel. 100 on top needs to go to the bottom. And 100 over 100 cancels out to 1. Lastly, pi. I know it doesn't look like it's in a fraction, but remember, any number written by itself is always over 1. We just don't write it. So technically speaking, this is a numerator. So this needs to go to the bottom as well. And the pi's will cancel out, leaving you with r squared on this side, which is a good thing because you want to isolate that in the first place. Now, the golden rule of solving equations, what you do to one side, you must do to both sides. So take this exact fraction and copy it over here, exactly as you see it. 360 times 350 over 100. If you can, keep things exact. So I'm going to try to calculate this without typing pi in the calculator. So 360 times 350 divided by 100. I get 1,260. 1,260. And since I didn't type pi in the calculator, as you can see, I did not type pi in that second step. Pi is still underneath the fraction. All right? So I've got an r squared by itself. The last step here is to square root both sides, because the square root and the power of 2 will effectively cancel, kind of like these did out to 1, but a different set of functions. So square root r squared, you get r. And this right here, you're going to round, so you're going to type everything in there all at once. Now, depending on the calculator level, it's going to look different. So this calculator is a bit older. It doesn't have the extended radical, so it has a set of parentheses, but it still works mathematically the same. Type that in. You get approximately 20.0267. So I'm going to round to the nearest 10, so 20.0. And since the area was in meters squared, the radius is in the meters. So what we've talked about so far is the area formula. The fact that there are 3 variables. In order to solve for 1, I have to give you 2 of them. It does not matter which 2 that I give you. You should be able to plug them into the correct spots and solve for the missing variable. That might be area of a sector, it might be theta, the central angle, or it might be the radius. Just a quick look at another type of problem. This one says, what is the central angle if the area of the sector is 46.4 square meters and the diameter is 14? Notice how they don't give you the radius here. They give you the diameter, but knowing the diameter is all the way across and only the radius is halfway, you can effectively take the diameter and cut it in half or divide by 2. And now you have all you need to find that central angle. If you're having trouble memorizing this or keeping it in the long-term memory, remember that part of it, the majority of it, is old. We already know the area of the entire circle formula. All that goes in front is the fraction featuring the central angle over 360.